Okay guys, I want to run through problem number 1 from your homework last night. So we have two vectors here describing a plane. We're talking about the velocity of the plane. Knots is a measure of speed. So we have a lightweight plane that travels first 20 knots in an east 60 degrees south direction. That means, again, 60 degrees south of east. That means that when you are looking at your protractor, you're going to put it on the compass mark that you'll draw out. The east line should line up with the 0, but the south needs to line up with the 90, which means I'm actually going to have to turn it upside down. So I'm going to have east over here on the right. South is going to be down here at the 90, and I'm going to measure the 60-degree angle in this direction. When you're looking at these, when you read them, the first direction is where the 0-degree mark needs to go. The second direction is where the 90 needs to go. Now our second vector is actually describing the wind on the plane. That vector of the wind blowing on the plane affects where the plane actually goes and at what speed. So the wind is blowing 16 knots in an east 20 degrees south or 20 degrees south of east direction. We're going to calculate the vector that the plane traveled. Before we start, I am going to make a scale drawing, and I kind of need to figure out how I'm going to divide that up. There's no wrong way to do this. You want to strike a good balance between using a large picture, but not so large that it won't fit on your paper. I'm thinking for a scale, let's say 1 centimeter equals, let's just divide it by 2. Say 2 knots. It's going to be pretty big, but I think I can make it fit. So I'm going southeast twice. So I'm going to start out like way up in the top left. So I've got lots of room to go down and right. I need to start out by drawing a little compass to measure from. North, south, east, west. And I need to measure 60 degrees south of east. So put your protractor right there, centered up, and then measure 60 degrees towards the south from the east. I've got a mark down here I'm going to draw towards. I need to draw a 20-knot line. That's going to be 10 centimeters in the scale that I've come up with. So, 10 centimeters. The drawing is really just so we can figure out what's going on. There we go. Let's go ahead and label before we forget. It's a good habit to be in. This is 60 degrees. Now I know this is 10 centimeters. I'm not going to write 10 centimeters. I need to write the actual value. That's 20 knots. Now down here, I'm going to draw my second vector that starts where this one ended. To do that, I need a new horizontal line, a new horizontal east-west line, so I can measure. Well, I can't just draw it anywhere. I've got to be consistent. If this is 60 degrees, I need to have a parallel line down here, which means I need another 60-degree angle here. That angle should be the same going in both directions. One way to do that, just spin your protractor around, pin it down at the end of your first vector, and then you can make minor adjustments until we're lined up with the 60 again. Now, I need to mark where 0 should be, and then I'm going to use a straight edge and those 2 points to draw my horizontal line. Now, I'm notoriously bad at drawing a straight line, even with a straight edge. So if you don't get it perfect, it's going to be okay, but you want to be as close as you can so that your drawing makes sense. Now, this is, again, a new east-west line. Let's go ahead and put it in a new north-south line. You don't really have to, but I think it makes a better drawing. Lets me really see all the angles. There we go. And now my second vector is going to start right here. It's going to go 16 knots, 20 degrees south of east. I am still holding my protractor upside down. So, 0's on the east, 90's on the south, 20 degrees is over here. And I'm going to measure 16 knots, which is going to be 8 centimeters. There we go. Put an arrow on the end so we know our direction. Vectors have direction and magnitude. And now I need to connect those two. My protractor is not quite long enough. Let's use this stapler as a straight edge. Rulers would be best. I'm going to rotate it for just a minute while I connect them. I need a resultant vector that begins at the beginning of the problem and ends at the end of the problem, as you might expect. I'll rotate it back around. This is weird. It's an obtuse triangle. We haven't done a ton of those, so you may not have seen a ton of these at this point. But now I need to answer two things. I want the resultant vector. The one I've drawn in blue here, that's the result. It gets me straight from point A to point B without all of this mess down here. Vectors have direction and magnitude. So I want to write a vector. We usually call the resultant vector R for result. And I want to write a vector just like what was given to me. It needs a magnitude, and it needs a direction. We can go ahead and do part of the direction now. I think it's going to be going the same direction these others were, just with a different angle. East-south, east-south, east-south. Specifically, I want that angle. I need to be measuring from the original compass, from the east line preferably. Sometimes it might be the west line instead, but the east-west line is usually what you want to measure from. Now, I don't know what theta is going to be yet, but that's what I'm looking for. And then the magnitude is going to be the length of this vector. I'm trying to give somebody else instructions so they could draw this themselves. This is kind of the way you want to think about it. I'm going to call this R. R for result. So let's go back to our drawing. There's some stuff I haven't labeled. Label anything you measured. This is 20. Make sure you labeled this as 60 because we did measure that. This is 16 knots. I want to find R first. We're going to find this with the law of cosines. It'll always be law of cosines for the magnitude. To use the law of cosines, I need two sides and the angle between them. I don't quite have that, but let's check. That's a nice right angle. That's 20 degrees. If this is 60, this must be 30. I've got a big angle here. That big angle is going to be 30 plus 90. 90 plus 30, that's 120, plus another 20. I get 140 degrees. So my magnitude, R squared, will equal 20 squared plus 16 squared minus 2 times 20 times 16 times the cosine of 140 degrees. If I want to get the R by itself, I'm going to take the square root of that number. So I'm going to throw that into my calculator. You don't have to do it all at once like I just did there, but you can do a lot of it at once. 20 squared plus 16 squared minus 2 times 20 times 16 times the cosine of 140. Let's make sure I'm in degree mode, and I am. I get 1,146. We'll take the square root. R is approximately 33.85658,641. The units will be knots, just like the other two were. I'm going to round that eventually. I'm going to write the whole thing for now. Let's go ahead and label it in here. 33.85659. Round it a little bit shorter. And up here, 33.857. This is the bare minimum I need. It's 3 places after the decimal. It's a good habit to be in for AP Calculus next year, or AP Stats if you take that. So now I want theta. Well, theta is not in the triangle. This angle is. Let's give that a name. I'm going to call it x. We haven't used x yet. I could find that angle using the law of sines. I know the opposite side, and then I know this opposite pair. I could say sine of x over 16 equals sine of 140 divided by that number I just found. I'm just going to say r, but it's this 33.8565. Well, I could solve that. Multiply both sides by 16 to get the sine x by itself. So then you'll get sine x equals 16 sine of 140 divided by this 33 number. And then to get rid of the sine, we'll do the inverse sine. That's all going to go in our calculator. Let's go ahead and do that before we get too far ahead. 16 sine of 140 divided by, I think if I scroll up I can find that 33 number without having to type it in again. Do the inverse sine of that. So x equals 17.684 degrees. This is not our answer, so be careful. That is the angle inside the triangle. Well, I know this entire angle is 60. If this angle is that 17 number, if we look carefully, 60 is the biggest of these. 60 is equal to theta plus x. So if I want theta, I need to subtract x. It won't always work that way, but this one did. So now let's say 60 minus that number we just found. So theta is 42.316 degrees. That should be our answer. The 33.857 knots and the 42.316 degrees. Let's check and see if that makes sense. Again, my protractor's not quite long enough to measure this, but that is roughly, really poor measuring job there, like 7.5 centimeters. Well, 7.5 times my scale of 2. Oh, that does not make sense, does it? 17.5. That was 17.5. What am I thinking? Sorry, this is 10 plus another 7.5. Let's try that again. You can tell I am not editing this video for content. So 17.5 times 2, 35. I got 33. This is the better answer, the 33.857. This just tells me that I'm not crazy. I made a good drawing, or I did my math correctly. At the very least, if I messed up the same way twice, which is unlikely, I think. So that seems like a pretty reasonable answer. And let's double check our angle. Again, I want the blue line. We center this back where we started. Like 44 is what it's looking like. I did not do a very good drawing, is what this is telling me. I'm off by a fair bit. But I'm definitely close. This is the correct answer, the 42.316. And again, it is measured from the east towards the south. 42.316 degrees south of east. This is a long process. But in general, you will always find the magnitude first with the law of cosines. And then you will use that to find the angle inside of the triangle. That angle inside of the triangle will be in some way connected to theta. Sometimes theta is bigger, sometimes it's smaller, maybe it's not inside the triangle, maybe it is. But you're going to find the angle inside the triangle with law of sines. Always law of sines, using the pair that you just found, using the law of cosines. You'll have to do a little thinking for this part, but you need to measure an angle from the east-west axis to your resultant vector. And that usually involves using law of sines to find an angle inside the triangle and then figuring out how those angles fit together. This part may vary, as will this part. However, if you go through these steps, use law of cosines followed by law of sines, you will be able to find everything you need, and then you just have to think about how it all fits together. All right, good luck.